Welcome to my presentation. First of all, I would like to thank Dr. Kafalengeton for providing us this opportunity. Today, I will try to present my project work on factors controlling the patterns of deforestation in case of Goba District, Bale Zone. My presentation has an outline. Introduction. Forest is dense trees and shrubs grows covering a large area with diverse types, species, and services. Forests are defined by different organizations in different ways. According to FAO 2010, forests is trees covering over 0.5 hectare, reaching minimum height of 5 meters, having a canopy cover of 10% and width of 20 meters. In Ethiopia, forest can be defined in different ways as well, but according to these writers or scholars, forests can be defined as a collection of trees with a mature height over 2 meters, a canopy cover of 20%, and an area of over 0.5 hectare. Recently, the Ethiopian Forest Declaration of this number has recognized high forests, woodlands, plantation, and bamboo forests as a forest. Forests offers goods, ecosystem services, habitats, socio-economic well-being, and recreational values, according to these writers. Forest degradation or deforestation is caused mainly by anthropogenic activities or human activities. Because of these human activities, in between 1990 to 2020, the loss of forest reached 10% of the forest coverage. When we come to an African case, Africa faces high deforestation rate due to population growth, weak governance, and climate change. When we come to Ethiopia, Ethiopia has lost over half of its forests since 1970s, according to this writer. In contrary, recent studies indicate that a slowing down of deforestation rate is occurring or indicating forest transitions. Well, forest transitions means, according to these writers, a shifting from net deforestation to net afforestation rates. Objective of this project: the aim of this study is to explore deforestation rates by focusing on biophysical factors, identifying forest cover changes, and developing a predictive model considering these factors in between 1919 to 2014. Methods and materials. The study area. This is the study area map of Goba district, which is found in the Bale zone, southwestern Ethiopia. The study area is embraced by a Sannate Afro-Alpian. The maximum altitude is found at Sannate, in the Sannate Afro-Alpian plain, specifically at Tullu Dimtu Point, which is 4,377 meters above sea level. The total area of the study area is about 1,510.5 kilometers square. The range of the temperature is 4 degrees centigrade to 25. Afan Oromo is the first language in this study area, and the main or the leading economic activity in the study area is the agriculture. Research methods. Descriptive research was utilized to access the forest cover change using satellite images. Biophysical factors like elevation, slope, and soil were considered during the image analysis. Procedures of forest cover mapping. Satellite images from 3 different consecutive, 3 different years were extracted using EtioGIS 2007. Image pre-processing and supervised classification were performed to identify the forest land and other land uses using QGIS. The forest land was selected and extracted as a single forest land, and the areas below 0.5 hectares were excluded and merged to other land uses based on the definition of forest by FAO. Procedures of this forest cover mapping using a asymmetric difference of 2 different years has been used to identify the deforested and afforested land were identified from the classified forest land images. Finally, MOLA model was used to identify the best area for afforestation and reforestation in the future. Sources of data: 3 different years of satellite image with 30 resolution was downloaded from USGS, and GOBA district shape file was collected from EMA. Similarly, DEM data was downloaded from STRM with the same resolution, and from this DEM data, elevation and slope was extracted. Finally, the soil data of 2007 was collected from EMA for secondary data use. Finally, the result and the discussions. Based on the interest of the researcher, the study area has been classified into 2 classes, that is the forest land and other land uses. Other land uses are considered as a single forest, as a single class, because the interest is to only extract the forest from other land uses. Based on this, the result of 3 different years has been calculated, and from the image we can easily understand that the deforestation is high or the forest cover is declining, whereas the other land uses are increasing. This shows us forest land is converted into other land uses, or there is a degradation in forest deforestation. So in that area, other land uses can be nowadays practiced on, and easily to show graphically the forest is become declining. The orange one is other land uses. Easily we can see it is increasing and the forest is decreasing while the other land use is increasing. To show the land use land cover map for 3 different years, this classification has been done by two forest land classes. The first one is the forest and the other land uses. When we see the 3 maps, in the central part, there is no forest cover due to high elevation. There is afforestation in the northern tip, whereas deforestation rate is high in southwestern area of the study area in comparison. These are the map which only shows the forest land. This has been calculated or extracted using a symmetry of 2 different years. And the next one is afforestation, deforestation, and the net reforestation, then to show the exact amount of forest degraded, deforested, and afforested area. When we see this from 2002 to 1990s, there is afforestation and as well as deforestation. When we see it, deforestation is very high, so the net change is 9,898 hectares of the study area was deforested, whereas when we come to 2014 to 2000, the afforestation rate and deforestation rate is a little bit closer to each other. So these changes, the forest change, net forest change is less than 1,000 hectares. The next one is to show the exact places of afforested area. We have said there is afforestation and we have said there is deforestation, to show locationally the position where afforestation is occurred. This map was extracted from the study area. This is the actual place of afforested area. This is the actual deforested area between 2000 to 1990, within 10 years. You see from this, when we compare the two images, the deforestation rate is high. And lastly, by overlaying the two, the actual change of the forest is this one. So the others, on the other areas also in different years also calculated, but for a time constraint, only the 2002 1990s only presented here. The next one is NDVI. NDVI is another parameter which helps us to know the afforestation and deforestation rate. Easily we can observe from these images. 2014, the degraded place is very high, and or deforested area is high when we compare to 1919. The green one is forest area, the others is the non-forest area. Analysis of biophysical factors. Spatial pattern of biophysical factor controlling was analyzed. Elevation, highest altitude were found in the central part of the study area, which has no forest cover due to high elevation. The northern and the southern parts of the study area have low latitudes and with low slope gradients, or low altitudes and with low slope gradients. The dominant soil type of the study area is chromic loamy soils, which is fertile and productive, especially in the northern and southwestern area. This is the graph which helps us, the map which helps us to show that the potential biophysical factors with the degradation. Prediction of the study area. Multi-criteria evaluation was used. Forest change was observed based on the factors and constraints. Suitability of forest was analyzed by a factor of slope and altitude, and the constraint considered was the river distance from the river and distance from road. The pairwise comparison was also calculated using Idrisi model. Based on this pairwise comparison, the consistency ratio was 0.03, which is consistent, and the consistency ratio for this project is acceptable. And lastly, to predict the future, area standardization of different criteria has been made. And lastly, the ranked factor map was also calculated, and based on MOLA, the prediction has been made. MOLA helps us for multiple and conflicting land use decisions to allocate conflicting objectives based on iterative reassessment. Finally, the estimated area was identified based on this map. Finally, the land use result obtained by MOLA after extracting shows us about 41% should be covered by forest and the other should be used for other land uses. As a discussions from 1919 onwards, afforestation and deforestation occurred at least elevation, particularly in the southern and northern part of the study area. The deforested area was greater than the afforestation. Generally, central part is not covered with the forest due to high elevation. The southern region has desert climate properties, and settlers from eastern Ethiopia are living in forest and cutting down those forests and converting into agriculture. This area is rich by teff, coffee, vegetables and fruits and grown properly, and the smelling is carried out in the study area. Toward the northern tip of the study area is highland, where crop production and animals is extensively cultivated. As a conclusion, study found there is a decrease in forest coverage from 55 to 47 in 2014. Accordingly, when we see in this year 10% of overall deforestation was there, factors like population growth, weak governance, and the climate change was contribute to a lot for this deforestation rate. As a recommendation to protect forest resource and ensure sustainable land use, conserving of forest through indigenous vegetation, promoting awareness among farmers, improving policy implementation, and reconsidering legal framework is very important. Finally, further research using remote sensing and geospatial technology is recommended for further understanding and addressing deforestation. This is all. If you have any question and suggestion, you are welcome. Thank you for your patience.